You are what you eat. The old saying is true not just for us as individuals, but also as society as a whole. Because what you eat can also refer to how the food we consume has been produced and ultimately how it landed on our plate.
It tells a story about our relationship with nature, our ecological footprint, and the resources we consume from farm to fork. New technologies have the potential to challenge and upgrade that relationship. Think of automated crops equipped with sensor systems, connectivity, and robotic swarms, vertical farming, or lab based meat, to mention just a handful.
Yet also the "you are" part receives increased attention as the impact of food on our body, especially on our brain and our genetic code, is understood better over time. We are able to add light and color to that story and improve it with new technologies such as Nutrigenetics or 3D printed food.
In this UTX episode, we provide a comprehensive look at the technologies which define the future of food and agriculture, and which are not just changing us, but also our environmental footprint and the way we set ourselves up with other species on not just our planet, but also beyond that. Let's explore.
Welcome to the UTX podcast, where we bring you a utopia created by technology, presented by your Techniax. I'm Val.
And I'm Ani. And today we're going to talk about three key areas of innovation around food and agriculture. Those are agriculture and farming, meat alternatives and food processing, and lastly, personal nutrition and cooking. Let's explore.
We start with agriculture and farming, so to speak, at the beginning of the supply chain where our food comes from. The major goals of technology in agriculture and farming in general are to increase yields, reduce harvest times, and reduce the harvest costs, and relieve the impact on the environment. Let's look at the major technology streams which propose such value for agriculture and farming.
One big idea is automated farming. And the idea here is to use infrared, electromagnetic, and even acoustic sensors in the cultivation process to conduct measurement in the crops, but also in the soil and the air. This ranges from pH or acidity or nitrogen levels, moisture, and even water quality based on electrical conductivity or EC in the soil. And it could also mean measuring nutrient level in the crops themselves.
Let's look a bit deeper into which technologies enable automated farming. And one of them is AI. AI can be applied onto the sensor data for tasks such as optimizing volumes and application times of water and fertilizers, or diagnosing ill plants, plant illness. Additionally, equipment sensors help with monitoring and managing machinery and warning about potential failures or malfunctions.
Another useful technology are drones, and they're useful for monitoring and surveilling crops, as well as for spraying the crops with pesticides, herbicides, or fertilizers in a more targeted manner, thus being more conscientious with their use of them.
And of course, robots can also be applied in agriculture. So-called agbots utilize GPS and sensor data, which supports them in the full agriculture process, which includes planting seeds, monitoring crops, removing weeds, and even harvesting.
Now, when we say ag bots, don't think of a big robotic scarecrow. They could even appear in the form of robotic swarms. To learn more about that, check out our last episode, episode 19. With the ISO bus standard, that a communication protocol that specifies control and communications on forestry or agricultural equipment, of course.
Now, this is how we use the existing farming space. But what if there was a way to use different space for farming and use that space more efficiently? And this is where vertical farming enters the scene. By stacking farming pots vertically on top of each other, farming space can be used much more efficiently, as we'll explore right now.
So, vertical farming reduces the use for agrochemicals and protects the plants from extreme weather conditions. It also doesn't cause any disruptions to local flora or fauna and makes farming possible all year round. And this because plants don't share common ground and can thus be very diversified.
These farming pots are usually indoors or in special locations that have the environmental properties needed for vertical farming to thrive. So vertical farming really has no geographic limitation. It can be applied to urban settings, allowing for fresher foods and reduced transportation and logistics cost. What's more, the farming technique can thrive without soil or sunlight because it utilizes artificial lighting such as LED and either of three ways to promote plant growth, either aeroponics, hydroponics, or aquaponics.
Aeroponics is when the plant's roots are exposed to and sprayed with nutrient rich mist. Hydroponics, which is the predominant system that will be used in vertical farming, is where plants are grown in a basin filled with nutrient rich water.
As an extension to hydroponics, aquaponics makes additional use of nutrient-rich wastewater from fish tanks. This wastewater gets purified by the plants using it in the harvesting process, and thus it gets recycled for reuse in the fish tank. So there is really a win-win situation going on here. The disadvantages of vertical farming include large fixed costs and high energy demands.
Let's move now further down the supply chain. Now that we're done with the harvesting process, let's look at tracking and optimizing, especially tracking and optimizing what happens to the harvest during its path along the supply chain. And this is very crucial to increase the quality of its product. Authenticated provenance, or the area where it is grown, um, utilizing the useful properties of blockchain is a very new way of tracing agricultural products as well as their surrounding conditions along their way from crops to shelf.
How this is done practically is by attaching sensors to the harvest, as well as the production facilities and or the transportation systems, such that the whole supply chain can be tracked and measured, including the harvest's origination, the duration of each step along the supply chain, the waste generated along those steps, as well as the surrounding conditions like temperature or humidity experienced by the harvest during inventory, processing, and transportation.
So the technology that we're talking about here would be blockchain. And what blockchain would do is store these data points in an independent distributed ledger with transparent, traceable, and verifiable transactions. Now it is able to trace the origins of a product within seconds, a task that would have originally taken days to complete. That's probably why, in collaboration with IBM, large food giants like Walmart, Nestle, or Unilever are applying blockchain to their supply chains.
Arguably, the most controversial new technology application to agriculture and farming is so-called genetically modified crops, or GM crops. GM foods are those foods which are produced using genetically modified raw materials, such as soybean or corn, but recently also genetically modified animals. Genetic modification is usually introduced to make the plants insect resistant or herbicide tolerant.
In the case of animals, genetic modification is introduced to get rid of allergens or pathogens, or to increase growth rates and protein levels. The what's being used are so-called mini chromosomes that are tiny genetic structures that can be added on top of a plant's existing genetic code, thus bringing along additional potential to add desired traits to a plant's characteristics, which would be a higher drought tolerance or manipulating the plant so that you would have to use limited nitrogen.
Now, GM foods is a real thing. So far, the US Food and Drug Administration, or FDA, has made 2 approvals for GM meat, so not that many, but still more than zero. First time was 2015 for salmon, and in December 2020, so just recently, they issued another approval for genetically modified pigs. The main concerns of GM food, and the reason that there are not more applications of it, as well as the crops, is related to ethical considerations regarding the genetic modification of animals, but also health concerns arising with the consumption of those related to allergic reactions, gene transfer from the food to the human body, and even unwanted crossings between weeds and other plant organisms.
However, there is a scientific consensus that genetically modified food does not cause more harm to the human body than normal food. However, the complex environmental impact of GM crops are not fully understood and might take years of research to fully be understood. To find out more about genetics and genetically modified products, we urge you to head over to episode 14 of our podcast. Of course, after you finish reading or listening to this one, head over there to learn more about genetics and GM products in general.
All right, so farming, agriculture is already very exciting. Let's head over to something which we almost daily experience now as consumers. We get a lot of advertising around the subject, and it's about meat alternatives and the differences and alternatives in food processing. The production of meat, as you all know, is a major producer of greenhouse gas and also a water consumer. It is also responsible for deforestation, land degradation, water pollution, and desertification. So you know that meat production does not have a good ecological footprint, let's put it that way. The idea of finding alternative modes of meat production has been around for a long time already. Even Winston Churchill in 1931 can be quoted as, "We shall escape this absurdity of growing a whole chicken in order to eat the breast or wing by growing these parts separately under a suitable medium." So he's not even complaining about the environmental footprint about meat production, but just about its inefficiency.
So 1931, that is 90 years ago. So this problem is definitely not something that has only recently uh, been in the public's eye. However, public perception around new forms of meat has still been quite conservative, but it is changing. So major factors that were mentioned in the research for people to consider them, or the alternative meats, let's call them, are healthiness, safety, nutritional characteristics, sustainability, taste, and of course, lower price. Now, several techniques have since been and are still actually being developed to produce meat in a more sustainable fashion.
Now, the way that this is advertised, the way that the value and the characteristics of those products are being communicated to consumers also plays a role in adoption. And in this case, consumers have been shown to like descriptions of the final product and its benefits rather than technical descriptions of the production process. And those technical descriptions you will hear from us now because we're Techniax and we like to deep dive into those things.
So yeah, don't close your ears, just hear us out. So the way that cultured meat is grown in the lab, either using animal cells that would be cellular, that would be using bioreactors and scaffolds, or protein from non-living material, that would be acellular, using fermentation. Let's take a look at this process.
And we start with the cellular version, which is produced by taking a small biopsy from an animal, extracting the cells from it. Usually those are myosatellite stem muscle cells, which can promote muscle growth in the new organism by specializing to become those muscle cells, as well as a growth serum. And the growth serum is added to the cells to multiply them, to nurture them.
Now, the cells can be used for 3D bioprinting purposes. That would be by creating a printing filament out of them. And this is actually being done by an Israeli startup called Aleph Farms, at no place less hostile than space. They took bovine cells to the International Space Station and bioprinted a small muscle tissue way up there. We'll dive into 3D food printing specifically in a couple sections from now.
If the cells are not applied in 3D food printing, they keep growing in the lab instead of being printed out. Now they will be placed inside a bioreactor with 37 degrees Celsius and around 5% carbon dioxide. This is similar to a brewery tank. They are then scaffolded into a structure. Additionally, flavor like vitamins and iron are added externally.
In 2013, lab grown meat was successfully done for the first time by Mr. Mark Post from the Maastricht University. And he grew the first burger patty directly from cells. And he also estimated that while lab grown meat today is still more expensive than traditional meat, it will definitely become cost competitive within just 5 to 10 years.
So if you listen to this carefully, you might have found out that we have a chicken egg problem. Because especially in cellular agriculture, we are still relying on animals because the problem has just been outsourced to somewhere else. Because the serum used to promote cell growth is usually fetal bovine serum, which is from a bovine or from a bovine fetal. It's taken out of the blood of a bovine fetus.
So, as an alternative here, the growth factors could be fermented out of protein. This would be similar to a protein fermentation process in the acellular agriculture, but this is, of course, more expensive.
The alternative input source to lab grown meat is non living material, which you would then call acellular agriculture, as we've already discussed. This works with protein extracted from milk, honey, eggs, cheese, or gelatin, and the extraction process is fermentation, where we use sugar. The bacteria used for the fermentation process are essentially filled with a plasmid. That plasmid contains DNA information of the desired proteins.
This whole thing happens in warm water. And in warm water, the bacteria are kind of active and they react with the sugar. And this causes them to grow and replicate. This solution is then purified using antibodies and centrifugation.
All right, so that's the production process now. So what? Common to cultured meat is the controversial discussions about its health benefits. While they may feature additional healthy omega-3 fatty acids more than in traditional meat, growth hormones might be added to the culture for mass production, which also might happen with classical meat. Regulatory authorities in major jurisdictions, such as the US and EU, already have established guidelines and approval processes for these meats.
But culture production would go much farther beyond meat, no pun intended. On January 20th, researchers from MIT announced that they managed to grow lab grown plants based on a newly developed method. And here they grew small wood like cell structures from extracted zinnia leaf cells. And while this is still very early stage, it could have very great implications for the environment, as the technique could partially replace agriculture and forestry. So think about, instead of having to chop down a forest or a tree or a family of trees for a new table, you could just grow your own table.
Which is exactly also what the MIT researchers thought about. They were also excited about their discovery. They went as far as hypothesizing about using the technique to produce lab grown wood used in construction and fabrication. For instance, to manufacture such a table that Annie has mentioned, right from the lab. So you have a lab grown table. Yet, as a word of caution, it remains unclear how feasible and efficient it is to scale that lab growing process for a table.
Yeah, so in the near future, if you want a table, you will still be going to IKEA, not to MIT. But another solution would be plant based meat, and this has caught quite some wind. One example would be tofu, and this is not just being consumed by vegans and vegetarians, but also people following, say, religious dietary laws. And these products have seen a partially massive decrease in demand during the COVID-19 pandemic due to the promise for a healthier diet.
However, nature has some clear rules, and when it comes to food processing, we know that almost any food processing step adds either of calories or chemicals, and most of the times both. So it's not actually the most healthy thing. In this case, their highly processed nature and sodium content make the claim of increased healthiness questionable. The base for plant-based meat most of the times is soy protein or soybean flour, as well as gluten, which in itself is not harmful, but during the processing, healthiness is usually not added, but rather subtracted.
In the production process of soy-based meat, soybeans are usually treated with solvents, alkali, and acidic substances to extract the protein, thus leaving behind any oil or carbohydrates before being washed and dried.
Lipids using soybean, olive, or canola oil are then added additionally to increase palatability, which means it tastes better. Plant-based food reached a market size of $4.2 billion already in 2018. So it is being considered by consumers as a viable alternative.
Exactly, and even more recently, companies like Impossible and Beyond Meat, who are pioneering creating plant-based or lab-grown meats, and even so far that large food chains like Burger King and others in the U.S. are featuring these vegan meat burgers. Definitely is a big promise that this market size will grow and that alternatives to meat will become more accepted and more widely available. Now, the last aspect is not a very, uh, shall we say, appetizing one, at least not yet, and that is insect based meat. Now, before you click away, hear us out. The consumption of insects is called entomophagy. And now the idea in itself is actually not new. Insects are quite common parts of the dietary plants in many parts of the world, and technically even lobsters and crabs would be considered not exactly insects, but not prime meats like goats or cows or pigs.
Exciting enough, but it gets even better because insect protein is really healthy. It contains a lot of B12, which is essential to meat based nutrition, as well as iron and calcium. The novelty of using insect for protein lies in the idea to industrially process insects to produce meat and protein bars instead of just eating the insects in roasted or warmed up fashion. The obvious advantages of insect meat are environmental because insect meat needs 10 to 15 times less water than beef and significantly less space to cultivate.
So from that we transition to personal nutrition and cooking. Don't worry, it's we'll move on to more appealing topics, let's say.
Not even
Uh,
sure.
well, let's find out. So we're moving on to the third aspect that we consider very critical for the future of food and agriculture, and that is, of course, personal nutrition and cooking. And as we're talking about personal nutrition, it makes a lot of sense to start right away with with personalized nutrition. So nutrigenomics is what we're calling, and this concerns itself with the impact of food on an individual's gene expression. That is understanding how nutrients interact with our genetic code on a molecular level.
And they do indeed so, and that's why I said I'm not sure if this is less gross than the previous part. Because if we have an example, cognitive defects are caused by the consumption of galactose rich foods like cherry or honey for those individuals that have galactosemia. So that's just one example of a disease that results from an inherited genetic deficiency of enzymes that power the processing of galactose, which causes then the sugar to build up in the blood. So understanding this better, understanding how food impacts our brain and impacts our genetics could very much play an important role in making us much healthier and happier as a species.
It definitely will, yeah. So several providers offer personalized nutrition plans based on the analysis of genetic information, and this offers great potential to optimize our nutrition to the needs of not just our body but also in our of our mind. needs in the future that would increase health, happiness, brain function, overall moods, and energy levels, and would just this sounds maybe overblown, but they do in fact lead to a better life. So nutrition is key, and personalized nutrition will play a big role in improving that for everyone.
Something that could facilitate, for instance, personalized nutrition would be 3D food printing, which we talked about before. And this allows us to automate the cooking or food production process and promotes variation by customizing food to different shapes, colors, textures, flavors, and even nutritional content. Food is printed using a 3D printer with additive manufacturing techniques, which means that it is printed out layer by layer, building up the end product subsequently or sequentially, rather.
So the uh, think of it as constructing every dish the way we make lasagna, layer by layer. But the applications of technology are, as usual, manifold. Customizing food to personalized nutritional requirements along the lines of balancing micro and macronutrients by also avoiding hard textures for elderly people, avoiding allergens by experimenting with and finding alternatives. These are just a sample of many great ways that we can upgrade our health.
Sometimes there are these startup ideas where you think, damn, I should have done that myself. And one of those for me personally is Nourished, which is an example of a startup from the Netherlands. I believe I'm not 100% sure, but they create personalized sugar free vitamin gummies. Those are individually packaged but plastic free. The 3D food printing process may also especially become useful on space missions to increase both the variety of the food as well as its shelf life.
Now, 3D food printing, not 3D printing, 3D food printing also has the potential to reduce waste by its means of predictability of required inputs, targeted ways of printing, and the potential to reutilize leftovers or distortedly looking vegetables or fruits, and maybe mixing them in purees and printing them in visually appealing ways. So I'm sure that many of you know that supermarkets waste a lot of food. They only pick vegetables and fruits that look in a certain way. And that essentially the starvation problem that we have today is not a short in supply, but merely a logistics problem. So, this using 3D food printing would mean that we wouldn't even have to massively upgrade our agriculture, but that we could, with the existing resources today, bring healthy nutrition to everyone using 3D food printing. So that's very exciting to
Just
end world hunger.
yeah, didn't want to interrupt you there because that's an exciting idea. Just like you can customize the appearance and build prototypes quite fast with 3D printing in manufacturing, you can also customize the appearance and presentation of food, allowing to perform, for instance, branding and creative designs on top of that food, which is a little bit less useful than ending world hunger, but still. And it can also be useful in something a little bit more interesting again, which is creating nutritious meals in shapes that are liked by children. So you could put your broccoli in a chocolate form.
But I think the idea of having a chocolate QR code on a chocolate chip cookie and handing those out instead of business cards are probably not just exciting, but also more effective ways of connecting with people.
Mm,
Uh,
indeed.
so the 3D printing techniques that are utilized in 3D food printing range from extruding the food through a nozzle, sometimes in hot conditions, to get the food to the point of being liquid for the simple manipulation of its appearance, all the way to sintering on powdered food materials using either a laser that will be in selective laser sintering or a liquid binder in binder jetting. So decorations and surface fillings can also be dropped onto the finished food using inkjet printing techniques. Now, if all these different printing techniques and uh, processes sounds unfamiliar, then check out our seventh episode on 3D printing to learn more about the 3D printing techniques and what 3D printing can offer us.
But as with so many other 3D printing applications, especially in food, it's not that simple to 3D print something. And the reasons for that are manifold. First of all, the printed product might not be finished yet and needs to undergo cleaning, baking, or frying, which is specific to food. Not all food is suited to be used in a 3D printer because it needs to be in liquid or powder form, but still remain stable after it was printed. The complexity of 3D food printing also arises from the different forms and structures of input materials, which makes the design of a 3D printed food product a challenge. No comprehensive software solution for the design of such products have been developed yet, so that would be a gap on the market. Given that the technology's application is majorly targeted towards consumer use, a specific software solution would also need to be intuitive and easy to use for those very consumers.
Another key challenge is the speed of printing, and this currently makes it quite infeasible for mass production. The speed is not only limited by how fast a printer can output materials, but also the specific properties of the materials and the time that they need to, say, harden or dry or whatever the properties of the final product. So this is definitely also a big challenge that needs to be overcome before we can make 3D printing a mass consumer option.
Now, if you like 3D printing, nah, I don't like that really, and you're a little bit more into robotics, here's something for you, because automation also does not spare the kitchen space. There is the London-based company Moly Robotics, and they developed a RoboChef, which is a robot capable of mimicking the motion of a chef cooking a particular recipe. This motion is actually recorded. The chef does that himself or herself by wearing a pair of wired gloves and a 3D camera, which enables gesture recognition and does the robot to replicate those movements.
So, after 6 years of researching and testing, Molly has recently released a robotic kitchen. That's a domestic robot that cooks and cleans up afterwards. So, it's
Truly
the
utopian.
full, exactly, the full package. What more could you ask for, right? The robot is able to recognize ingredients and cook pre recorded recipes. So, you just have to show the robot how to make your favorite spaghetti dish or your favorite pizza once, and it would be able to do it flawlessly every time. However, the ingredients still need to be prepared and filled in boxes ready to cook. But I'm sure that within a few years, all you'd have to do is uh, send your, or probably your nutritional diet plan that is connected to your phone will tell the kitchen to prepare it in the exact time that you get home and have showered and are ready to eat. But more on the utopian day later.
Yeah, the old days of the chef, of the human chef, are not over yet. The solution also is still quite expensive, so still some time is needed for this to be developed further. If you want to learn more about robotics, and we keep saying this because that episode is featuring a lot of interesting applications on robotics, you should check out our latest episode, number 19, on robotics and software robots.
So let's stick with Mole for just a little bit. Mole also offers their X Kitchen, and that's an IoT cooking platform with a smart refrigerator. Now, a smart refrigerator isn't just a TV screen and ice dispenser on its door. In fact, it is a connectivity-enabled fridge with several add-on functions, which can partially be controlled by a smartphone app and a digital screen.
Talking about that screen, it might allow you to do grocery management by quick identification of the fridge content. And oftentimes the fridge has a camera inside to allow you to do the same remotely. So
Wow.
you're standing in the supermarket and you're just opening your app, and via
Wow.
those cameras, you can look inside your fridge and check out what is there. Smart fridges are being manufactured by smart home giants like Samsung is one with their Family Hub series, or also LG with their InstaView product system. So InstaView is not just the stories on Instagram, but apparently that's also a kitchen system.
And additional features that are common also include voice control of the fridge temperature or icing machine, or maybe even connecting with other in house IoT systems like the actuation functions for IoT devices in a smart home.
Now, something I was surprised to not have found yet, but in the future should definitely happen, and I think consumers will also demand it, is that those systems themselves recognize the fridge content using something like computer vision or sensors in collaboration with a text scanning system, which would then bring them one step closer to grocery automation because it could automatically order based on either an algorithm or preferences that you've defined. It could order a refill to your groceries.
That already sounds like you're in the next segment, so why don't we just skip over to the utopian day in the life of us Techniacs? That would be this time powered by agriculture and food or emerging technologies in these sectors. So, how would this look like? So, first, I get up on this beautiful Saturday morning and I check out my personalized nutritional plan. And it has been created based on nutrigenomics and genetic information that I have provided. Of course, I provided it as homomorphically encrypted data, which means that the company's AI could train my data and give accurate results without actually knowing what the data is or to whom it belongs. So I am able to hand over genetic information without being afraid of any data privacy issues. And my meal plan actually even accounts for hidden allergies that I've previously not been aware of. So it's pretty great.
Yeah, let's take a bit longer with this because it actually is really exciting. My nutrition has upgraded my life by multitudes. It has massively increased my health and immune system. While I don't have a brain computer interface yet, it feels like I would already have one because nutrition helps me with my brain. It works much better and I'm feeling much happier. It has also increased my energy levels throughout the day. It has massively boosted my performance. I can now plow through a day, through a very busy day, including mentally and physically exhausting activities, without ever feeling tired, still having some gas left in the tank at the end of it. And this is not based on some woo-woo technology, but just understanding better how nutrition affects my body.
All of this, and I haven't even had breakfast yet. That's how utopian this day is. So it's time to get some of that life enriching food for breakfast. So I walk over into my smart kitchen and I'm greeted by my cooking robot that has a silky smooth AI voice. And it's part of the fully automated smart cooking system. I actually ordered some pancakes with bacon, and the cooking robot walks over to the smart fridge, takes out the ingredients, and the smart fridge automatically adjusts its inventory levels by reading the barcodes of the removed product. So, very similar to the way the brick and mortar stores of Amazon work without any person in there. So, my RoboChef's AI has learned how to cook the dish based on thousands of dishes given to him from the operator's database, and thus he can adjust the meal to my personal preferences anytime simply by voice command. And my smart kitchen seamlessly interacts with the cooking robot, and it also offers supply of cookingware, supply of dishes, cooking systems, cleaning, and the dishwasher. And I felt a bit bored this morning, so I took some time to watch in a maze. So I was just able to sit there and watch this robot cook the perfect breakfast, automatically update my inventory, and offer serve me the best breakfast I've probably had. I didn't have to lift a finger. Otherwise, I'd have to get up, go do everything. This time, I just get to sit back and enjoy.
Now I voluntarily decide that I do want to lift the finger. And this is because my smart fridge signals me that the threshold of missing inventory for grocery shopping has been reached. So it essentially tells me that a couple, like a dozen items are below threshold, which is what I have defined as, okay, please signal me it's time for grocery. So it asks me if I want to do it myself or if I just want to order by voice command using the connection that it has to the online shopping service. I decide to go for it myself and have a nice walk in my city Utopia.
So as I'm arriving at the retailer, I'm checking for vegetables, and all the vegetables are grown locally, sourced locally in my city Utopia. And I heard they use vertical farming with hydroponics in nutrient rich basins filled with water. It all sounds very interesting and exciting. And based on my retailer's mobile app, I can simply scan a foods bar or RFID code and check from which vertical farming station my veggies come from, when they were harvested, how long it took them to arrive in the shelf, whether there were any damages or problems on the way. I have a complete overview from farm to fork.
Amazing. So I packed my groceries, and on the way out, I passed the home and furniture section. I see an advertising banner there. It writes, "Buy the first fully lab grown furniture collection here." Wow. It looks quite stylish, so I asked the salesman about more details regarding it. She tells me that their supplier uses lab grown wood and synthetic material to manufacture the furniture by design. So no manual or even robotic work is involved. Wow, crazy. He tells me how much, or she rather tells me how much CO2, energy, and water is saved by manufacturing the furniture in this way in comparison to traditional furniture. I'm really gazing in excitement.
So I come back home from my long day of shopping. I haven't done this in a while. Actually, my robot has been doing everything at home, even around home. So it's dinner time, and I'm in the mood. Well, why not cook a meal old school, all by myself? Not as old school and not as myself as you might think, but quite old school. So I'm preparing some nutrient-rich dish that's featuring rice, insect meat, and vegetables. And I know it sounds a bit weird, but you really don't taste it. Don't worry. Everyone's had this for a while, and using special techniques that my cooking robot has, you don't even taste. You don't even think that you're eating insects. You wouldn't be able to tell the difference. My cooking robot starts preparing the vegetables, but I still make the meal on my own by giving the dessert a bit of a personalized spin with the help of my 3D printer. And I'm able to create a fruit chocolate combination that looks like fruit, tastes like fruits, but also like chocolate and caramel. So that's pretty tasty. And it doesn't just conclude my dessert, but it also concludes just one aspect of my very utopian day that's been enlightened or empowered by emerging technologies in agriculture and food. So I can hardly wait to go to bed and start all over again, full of energy and full of awesomeness, for lack of a better term.
I hope this has been a very tasty and energizing episode, not just to us, but also to you. And if you enjoyed this, remember that you can subscribe to us on YouTube. You can follow us on Spotify, Apple Podcasts, Google Podcasts, Stitcher, and also any other major podcast platform, as well as in written form on our Medium blog.
And further, you will find that we're sort of transitioning into a new phase. UTX is now not just pumping more information, but we're going to take the whole thing into a new direction while still maintaining our utopian day in the life. Don't worry, that will still be a central aspect, but we're now going to bring in some more brain power, shall we call it. But we'll make an announcement next week. Don't worry, we'll keep you posted. And until then, stay patient, stay healthy, stay safe, and as always, stay utopian.
Your Techniax.